Welcome everyone to lesson 3 of the full-time GoDev program. And in this lesson, we are going to take a closer look at the generic types, not generic types, the general types like integers, floats, and all that stuff. But we're also going to take a look at structs, maps, slices, arrays, and also custom types, right? Interfaces is something we're going to cover later on. I see you already thinking it's a very important thing. Golang interface, mastering interfaces makes or breaks you as a top Golang engineer. So we're going to make a special lesson about that later on. So in Golang, we already covered variables, right? So now we're going to take a look at general types, right? In Golang, we have, for example, let's do some vars here as global. And we're going to say, for example, a float. Of course, we cannot... I'm thinking about how I can basically... a float var, let's call it a float var. And a float var is going to be this, right? We're going to have a float var. We're going to say it's going to be a float 32, right? This is a float 32. A float 32 is basically smaller than a float 64. It is what it is. Float 32 is 4 bytes. A float 64 is 8 bytes, right? Very simple. You could already think by yourself, when do you use a float 64 or a float 32? Well, to be honest, you always use a float 64 in my opinion, right? Especially right now, we are entering 2023, only 2 weeks left. So basically, always use a float 64 in my opinion, right? But sometimes maybe you could have a float 32, but don't worry about it. Use float 64s and don't worry about it. So we're going to say float var 32, I'm going to call this, and float var 64, right? Then we, of course, have the strings. We already did this. Name is going to be a string, which is just foo, for example, right? We need to specify an equal sign. My bad. So name, we can also have integers, right? And we have a whole bunch of integers. And I was thinking, do I need to cover all these integer types? Of course not, because you will see we're going to cover that later on in our projects and stuff. You're going to see me use different integer types, and I'm going to explain why I'm using that specific integer type, right? So we could say an int variable 32 is going to be an int 32, which is 1, for example. We could also have an int var 64, which is going to be an int 64, and that can be a larger number, right? That's the reason int 32 is 4 bytes, int 64 is 8 bytes, so it can carry a bigger number, but hey. Normally, you would always use an integer, unless, because it's less memory, right? Unless you're going to store a big number, right? So it is what it is. So basically, if you want to use an integer, always use this, right? Int var int, just like that, and it's going to be 10, for example. And of course, we could also have a uint var, and we say uint. Simple, and that's going to be -1. We can't, right? Let's make this -1. Why can we make a uint -1? Because it's an unsigned integer. It basically means it's unsigned. It cannot be negative, right? So it needs to be positive. Of course, we have an uint 32 var, which is basically a uint 32, and you already see it coming. We also have a uint 64. Actually, yes, we have a uint 64 like this, and it's going to be whatever you want, right? So you can see that are basically the integers, and yeah. So basically, we also have a uint 8 var. And that's basically the same thing as a byte, a uint 8, uint 8, what am I doing? It's going to be, for example, 0x2. It could also be 1, right? But it cannot be this. You see what I mean? Why? This is too big for uint 8, until 100, right? Because we cannot do, it's not going to work. You know what I mean? 4 digits is not going to work. 3 digits is going to work, right? So it's basically a byte, and you can specify it like this or like an integer. It doesn't really matter. We also have the byte var, right? And the byte var is basically the same thing as a uint 8, right? This is a byte, and a byte can be 0x1, 2, and all these byte shenanigans. It doesn't matter. So basically, a uint 8 and a byte are exactly the same. We're also going to have a rune var. A rune var is basically a rune, and a rune needs to be specified with these single quotes, right? And it's going to be A, right? A rune is A. What is a rune? It's a rune. It is what it is, and we're going to specify this with these single quotes, because double quotes, A is going to be a string and not a rune, right? Very important. It's a rune. If you index a string, we're going to see that later on, you're going to also have a rune, right? So that's a rune var. I probably forget a lot of shenanigans here, but I think I covered the most of them, floats, ints, and all that stuff. I think that's fine, right? Those are basically some general types, right? Then we are going to get the structures, right? So in Golang, we have, for example, we're going to say struct. Wait, it's going to be type. We're going to say type here, very important. We're going to call this a player, and this is going to be a struct, right? And then we're going to close it, right? This is going to be an empty struct. Simple as that. It's not going to occupy any memory. It's empty, an empty struct. So what does a player most of the time have? A player has health, right? Health. And health is going to be an integer. Perfectly fine. That's how we define a struct. So we have a player, and we have one variable inside of it, one kind of a state in that struct, and that's health. And we can also give it, for example, a name, right? We have a player, and we're going to give it a name, and maybe we can also give it HP. That's all. We already have that. Let's make it attack power, right? Attack power, and that's going to be also an int. Why not? Let's make it, or maybe a float 64. Why not? Right? Let's make it like that. Cool. So basically, this is our struct, and how are we going to, this is our definition of our struct, right? The definition. So how are we going to call our player? Well, it's very simple. We're going to say p of player, and then we're going to do this colon equal, right? It's basically, hey, because otherwise we need to do something like player, right? Just like in these Java or C, or in C++ and all that stuff. But we can infer the type with this colon. So we're going to say player is going to be a player, right? And if you do this, right, let's make this player an empty player, right? We can do that. Let's print out. But I'm going to teach you something. We're going to print f. That basically means print formatted, right? Println is print align. Print format, printf is print formatted, so we can actually do something like this. That's how we format a string in Golang. We're going to say this is the player, and I'm going to say a percentage v, and percentage v stands for, I don't know actually, I think it stands for verbose, and this will print out any kind of type actually in a verbose way. So we're going to say player, we're going to put the player inside of here, and of course, because printf will never make a new line, I'm going to do a new line here, so we have no issues if we print something below that. So let's do go run main.go. You can see this is the player, and what you see is we see nothing here, right? Because it's an empty string, like I mentioned before. Golang will initialize its empty variables with the default state of that variable. And for a string, it's an empty string, so we don't see it. But for health and attack power, it's going to be 0, because the default value for an int is 0, and the default value for a float is also 0 or 0.0, right? So that's our player. So how can we actually instantiate this player with some variables? Well, that's very simple. And I'm going to teach you directly how you should do it, because there are some couple ways. And actually, I'm not going to teach you the bad way. I'm going to teach you the good way, and you can figure out the bad way yourself later on. So what you're going to say, first of all, we have name, colon, and the name of the player is going to be foo. Let's make it Captain Jack. Right, that is our player. Then we're going to say the health. This is wrong. We're going to say the health of the player is going to be 100. And we're going to say that the attack power of the player is going to be, I don't know, maybe it's going to have 45-1 attack power, right? So that's basically our player. Pretty nice. Then we're going to say go run main.go and see what's being printed out. We can see Captain Jack 145.1 attack power. Not quite sure if that's good or bad. You tell me. So how can we print this basically a little bit better out? What I'm always doing for structures is do plus v. Boom. You see? I do plus v. Why? You will see. Go run main.go. Boom. Now, if we do plus v, it's going to be the super verbose mode. It's where we're going to see the name is Captain Jack, the health is 100, and the attack power is 45.18. That's basically a structure. Very simple. No big of a deal. But in our structures, we can actually attach functions to them, right? Because, like, let me do this. We could say, for example, what can we do? Get health. I'm going to make it small caps, actually. Get health, just like that, health. And we're going to return what is the return type of our health. We're going to cover functions, actually. Not quite sure if I'm going to cover functions, to be honest, because, like I said, a function is very simple. If you don't have any programming experience, it actually doesn't matter, because we cover them actually throughout the whole program, and probably you will have some experience in maybe another language, functions, right? No big of a deal. I'm not going to teach you how to program from scratch, although I'm pretty sure that if you're coming from nothing, you will be a professional if you follow this program, for sure. So we're going to have health. It's going to return an integer here, and we're going to, because we don't have the player, we're going to put the player as an argument. So we're going to say player, which is going to be a player, right? That's how you do arguments in Golang in these functions. You're going to basically say first the name of your variable and then the type of your variable, right? Pretty simple. And then we're going to say return me. We always need to return in Golang. We're going to say return player, right? Player. And we're going to say dot, right? Dot. And you can already see all the variables that are basically attached, assigned, available for this player, and it's going to be health. We're going to return that, right? And then we have this player here. We are going to, this is the player health, just like that. And I'm going to basically do, for health is an integer, and the format directive for an integer is going to be D, right? But don't worry about it. It's not that really important, but hey, good to know. So we're going to say here, we're going to say get health, and then we're going to put in this player, right? And let me close. I think it's fine enough. Right. Let me actually do this so it fits on the screen without deleting or how do you call that? Curriculum. I don't know. You understand what I mean, right? So we're going to print the health, and it's going to be get health of the player, right? And it's normally should return 100, right? And let's make it clear, 101. So we're going to go run main.go. Boom. You see, the health is 101. 101. It is what it is. So easy. But, very important, in Golang, you can attach functions to your struct, and you call that a function receiver. So we're going to make a function receiver of this player. How do we do that? It's very simple. We're going to say func p. Most of the time, you could also do player, right? Let's do player. Let's make it simple. Func player, which is going to be a player, right? And then we're going to specify the name of the function, get health, right? We don't need to specify the player here anymore in the arguments. Why? Because we already have access to the player here. Eh? We're going to say integer, and then we can actually access the player here, right? We're going to say player health, boom. And then we can basically delete this function, right? And here we have our player. What we could do here is, instead of calling get health, because that function is in the dumpster, it's not existing anymore, we can say player dot get health, and we don't need to specify anything here because we have access to the player here, right? And it's going to return the health. Go run main dot go, boom, the same thing. And you can already see it coming, right? But you don't need to have, basically you don't need to specify a getter for this. You could directly actually access the health here, right? You could say here, delete this function, health, and call it a day. And this basically going to be the same thing, right? Go remain not go, boom. It's the same thing, right? But you can attach functions to your structures, which is calling. You can make function receivers for your struct, and we're going to cover that. You can, oh man, you will see this all the time, but this is just like an introduction, right? Cool. The next thing we're going to have is maps. So a map is very simple in Golang. A map is basically this. We're going to say, for example, users, right? And we're going to say users is going to be a map, right? A map of, it's going to be a map of strings to ints, right? Because this is going to be a map of users with their age, right? We're going to create a mapping of all the users' names and the age of that user, of that corresponding user, right? So basically, it's very simple. We're going to say we can initialize a map in two ways. You could do it like this. This is going to be an empty map, right? Empty map You see, you could also say, I don't want an empty map. I want to directly specify, for example, what's going on here? Anthony, which is my name, and I'm going to say my age is going to be 36. Boom. Just like that, right? This is not going to be an empty map. This is going to be a map with already one user and a map to the age already in there, right? So basically, this is how you initialize an empty map. And then we're going to say here, we could do users foo is going to be 10, right? That's how you actually, I need to do it like this. Users foo is 10. Okay, and then we could do users bar is going to be 11, right? We can also initialize a map in another way. We could do it like this. For example, users is going to be make, the make keyword. And we're going to cover that. Although you don't need to actually know exactly what it does. It basically makes a new default thing of certain types in Golang. I don't want to make it too complex for now. Most of the time, you can always initialize this just like that. And I think this is basically more of an idiomatic way most of the time, right? But I just want to show you, you can say make, and you just specify the same thing as above. Map string to integers, right? That's exactly what you could do. So you tell the compiler, hey Go compiler, make me a map of strings to integer. Done, right? And you could do the same thing, right? So these two are basically exactly the same, right? All right. Let's print a map, so we could do exactly the same thing. We're going to say plus v because it's a map and I want to see everything. We're going to say users here. Users, boom, boom. Go run main.go, boom. And you see we have a map, bar is 11 and foo is 10, right? Super easy. How can we access a map, a variable of a map? That's very simple. For example, my alarm is going off. Alarm is going off. Let's delete that stuff real quick. We could say, for example, age is going to be users foo. Right, and then we could do here, let's print out the age. And what is age? Age is an integer, so we already know it's going to be a percentage %d. We're going to call age here. Go run main.go, boom. You can see the age of foo is 10, right? And of course, we can do the same thing with bar, very easy, bar. And let me try to find this, boom, 11, right? Hey, like we expected. The next thing is, how can we check if a key exists in the map? It's very important because what happens if you do this? Bus doesn't exist, right? Let's do bus here real quick. Boom. Age is 0. Why? Because, like I said, the default Golang will always make the default initialize everything as a default variable as 0, right? So it's going to return 0 because actually there is no int, but still there is an int because it knows that it's a map string of ints, so it will make this a 0, which is actually very bad because it will shoot you in the foot because you think here that bas exists, but it isn't, right? So what we can do in Golang is we can do this, right? We could say the age okay. Right. The second variable here, you can call it whatever you want. Most of the time, we call it okay. You could do exist, right? Because this variable here is going to be a Boolean. Look at this. You see, what exists is a Boolean, right? And most of the time, guys, very important, do okay, type okay, because okay is a community Golang idiom, right? So we could say age okay is users bus, and then we could say if not okay, we could do you could say fmt print ln bus not exists in the map, right? And what we also could do is else, right? Else we're gonna print bus exists in the map, and we could do like this. Also in println you have one chance to place another variable on the to format a variable, one chance, one opportunity to do that. So we could say here age, right? And then we're gonna delete this here and run this here, boom. And you see bus does not exist in the map. And if we make this bar, right? Go run main.go real quick. I'd rather use my arrow keys, but hey, bus exists in the map and it's 11, right? So, okay, I did a mistake here. If it exists, we're gonna say bar actually exists in the map. And it should be fine. Boom. Bam. You see, existing map, it's 11 because we are calling bar. All right, the next thing what I need to teach you is basically how can we delete. Well, delete is very simple. You're going to do it like this. Deleting, let's do this. Hop, hop, hop. For deleting, you say delete, the delete keyword, right? Only applicable to maps, actually. And we're going to say delete. What are we going to delete? We're going to delete users. And what's the key we're going to delete is foo, right? So if we now print out... can I print a Landis map real quick? I'm not sure. Let's try this. Go to me, not go. You can see the map is bar 11. Why? Because we deleted foo and 10 is out of the game, right? That's how you delete in maps. Very simple. How can we range over maps? Well, that's also a very simple thing. We're going to say for the key and the value colon equal range over users, right? And let's print out the K. We could do a printf. We can format this. Why not? Why not? We're going to say this. The key is this as an S, right? Because it's a string. And the value is going to be %d. Why? Because we assigned integers, right? And that's the format D. And then we're going to make a new line. Otherwise, it's going to be nasty. And we're going to say KV and run this real quick. Boom. You can see the key foo and the value is 10. The key bar and the value is 11, right? You could also do this. You can delete the V here. So there is no value, only keys. You cannot range over values, right? You could range over values, but then you need to specify the key and the value. But you could also range over keys and only over keys if you want. And then you just specify for key, actually here. Range users, and then we're going to do this. Delete the value. The key is this, right? And it's not K, it's key. And then run this, boom, bats. The key foo, the key bar. That are basically maps in a nutshell. Cool. The next thing we're going to cover is slices. Slices is very simple. A slice and go is basically, for example, let's say numbers, right? And we're going to assign numbers, and we're going to say this keyword, you know this. This is basically the array or slice keyword. Not keyword, but the shenanigans, right? And we're going to say var numbers is basically a slice, right? Because there is nothing in it here. There's going to be a slice of integers. And the same thing, like in maps, we're going to instantiate it like here. Or we can put, we cannot only put integers here in like this. 1, 2, 3. Or we could also say other numbers. And that's going to be another way to initialize this is say make keyword, right? And the thing is with the make keyword here, we need to specify how big the initial size of the slice will be, because a slice is dynamic. It will expand and despand. How do you call that? Along the way. So basically Go will manage that internally. So we need to specify the length, the initial length of the slice. And we're going to say 100 or something, and then it's actually we don't need to do that. You could do make slice integer and do 1 or something, right? There's other numbers. But most of the time, guys, to be honest, I'm always initializing my numbers like this, my array, my slices like this, right? Because this is a bit awkward in my opinion, because right now you have a predefined value and you also have a cap, but I'm gonna spare you that. It's not necessary. I'm basically never or almost never use it, and I don't want to overburden you with complex stuff, right? That's my way of teaching. All this complex stuff will come over time. That's important, because otherwise you're going to be full of brain fright, right? Brain freezing, all that stuff. So we have other numbers. So basically, let's print these guys out to show you guys real quick. Let's delete all that bullshit. We're going to say here, fmt println. We're going to say numbers here, right? And then we're going to do the same thing with other numbers, others. Let's make it big and boom. And let's print it out here. Boom. You could see, in this case, we have an empty slice just by initializing it like that. But in this case, we have basically other numbers like that. And actually, to be honest, and we have already two spaces allocated, which is basically allocated with the default value, once again, with the default value of an int, which is 0, right? But actually, I'm testing, can I do 0, to be honest? Yes, I can. Well, that's going to be the same thing. Let's clear and run it again. Yes. Okay, cool. So that's basically the same thing. That's actually more correct. So you can initialize an empty slice with these two keywords, and you can loop over slices and all that stuff. I'm not gonna show you this. It's gonna take too much time. Doesn't really matter. Looping is the same thing as over a map, right? It's just a for range or just a simple for loop with an index. The next thing is basically arrays, and arrays is basically the same thing. You could say this, but an array is a prefixed, right? A slice can expand, can increase and decrease, but an array can't, right? Once you say that these numbers are two of integers, it's gonna stick like that, right? It's gonna stick like that. So we can never do something like this. To append stuff on a slice, we're going to do it like this. For example, numbers is going to be append, right? This is how you append a new number onto a slice. We're going to say append numbers, and we're going to say 1, for example, right? And that's going to be a problem, because the first to append must be a slice, and it's basically an array. We can use that. Right, we just can't, right? Because it's a prefixed numbers thingy. The only way we can add to this numbers thing is by doing this, right? Numbers 0, actually 0 index is going to be 1, and numbers 1 is going to be 2, for example. That's perfectly fine, right? For a slice, right? A slice is dynamically can dynamically grow. So for a slice, we can do that. We could say numbers is append, and that's going to be numbers, and then we could say 1, right? And we could do even 10, right? And then we can print it out, fmt println numbers, just like that, and run it, boom, and we're going to see 1 and 10 inside of our stuff, right? That's basically how you do that. If you want to delete that stuff, that's a whole other beast we are not going to cover in the introduction video, right? It's complex stuff. Too complex for now, right? The next thing we have is custom types, and custom types is very simple, actually. For example, we could say var player, for example, var weapon, right? And var weapon is going to be a string, for example. No, it's going to be var weapon string is going to be an X, for example, right? But you could do a custom type for that. So we could do something like this. Var a weapon is going to be actually type weapon string, right? Gonna delete this. So my ears are burning. So we're gonna say type weapon string. What does that mean? Exactly how it is. You're telling the compiler, hey, I have a type that is called weapon, and that's going to be a string. So that basically means that if we are going to do something like, let's make a function. We're going to say get a weapon. I don't know. We're going to say the weapon. Actually, we're going to say W. Let's make this type actually caps, so we can do this a little bit better. So we can name this weapon, and this weapon is going to be a weapon. And we're going to return a string in this case. Return fmt. Actually, no, we're going to do this. Return the weapon. Weapon, just like that. And you can see that it's not going to work, right? Because why? Even though we are specified, actually, yeah. Even though we are specified that the weapon is a string, it's a very hard typed language, right? So you could see, very strict typed language. You could see that we are returning weapon, which is actually a string, right? But it doesn't allow us because weapon is of type weapon, which actually is a string. Super complex, but that's how you can actually make your custom types, right? Enable to return this weapon, we can do some complex stuff like this. We can cast this to a string if we want, and it's going to be all fine. But like I said, we can go very, very, very in depth in these things, and I don't think it will benefit your dopamine levels. So that's all stuff that we're gonna cover along the way, right? We could also, like I said, for example, here we already did it, right? We say type player is going to be a struct. It's the same thing. It works the exact same thing, right? We could also say, for example, type, for example, a specific version is going to be an integer. It's the same thing. We could make as much types as we want, our own custom types, and it can be confusing right now, but this is going to make so much sense later on. But now you already have a heads up that these things are possible, right? Especially when we are covering enums in the future, right? So like I said, it's very hard for me to determine what I'm going to show you or what I'm not going to show you, because like I said, I know perfectly, like my teaching style is unique, and I know how people learn, I know how people can digest these things, and by making it simple and straight to the point without going too in depth, because that's going to kill, like I said before, it's going to kill your reward system. It's going to completely shut down your dopamine levels, and we are going to cover all these advanced mechanics along the program for sure, right? And I'm looking forward to see you in lesson 4.